Hello and welcome to this presentation. For this video, we're going to be talking about the latest enhancements for SNMP in AOS-CX 10.10. So there are quite a few enhancements that are coming out for 10.10. For SNMP Read, we now have a single OID for average CPU and memory to view the average CPU and memory statistics. For SNMP Write, we can now write for PoE priority, port security, port speed and duplex, and config management. And the new traps that have been introduced in 10.10 are inserting, removing, and having an unrecognized module for our chassis-based platforms, running config changes or any other kind of config changes, insertion and removal of transceivers, port security, AAA server status, and SNMP authentication. So for the average CPU and memory to read those values from the OID, we have for the OID specific to that, which you can see the top one here ends in .3. If we do an SNMP walk in the switch for that OID value, we can see that it returns a 16, so that's the CPU. And then for the bottom one at .4, we get the value 26. So if we do an SSH session into the switch, and we do a show system, we can see those are the values, average values for both CPU and memory. Before, we would see each core of the CPU, or basically it was for the core of the CPU, so we had a lot of requests to be able to show the average value for the CPU itself. So now in 10.10, we've enhanced this feature to be able to do that. Moving on to our SNMP Write enhancements, first we'll have PoE priority. So as we see here at the top, if we run our SNMP set command to change the priority of, so in this one, we can see the whole string here for the PEF, PSE, port, power priority, the index, port index, and then the actual port number, which is, I'm on port 3 here. So the 3 equals 1/1/3 as we would see on the switch interface table. I'm going to give that as an integer base, so I'm going to make that critical. So 1 is critical. So I'm going to set it to 1, and then we can see that it returns critical 1. So then if I log into my switch and if I do a show power over Ethernet brief, we can see highlighted here on 1/1/3 that the PoE priority has been set to critical. For port security, writing to port security, so I'm just going to enable port security on the port itself. So once again, I'm using the SNMP set command to write, and the OID string that we can see here at the top, I'm going to be the last number, the last digit there, the .25. That is port 25 or 1/1/25. So I'm going to give that an integer of 1, which is on or enabled. And if I log into the switch and I do a show run interface 1/1/25, as we can see highlighted, port security has been enabled on that port. We can also use various options for port security and writing values to that. We can enable port security globally. We can enable it at the port level. We can add a client limit at the port level. We can set a violation action. We can set a violation shutdown recovery enable action, both at the port level. We can set a violation recovery timer at the port level. We can do a port security sticky learning, basically sticky MAC address learning, enabling or disabling that. We can do a port security sticky static client MAC address addition, or we can enable a trap on the sticky MAC client, on a sticky MAC client move violation. So we have the ability now to do a write for port speed and duplex. So if we take a look at the slide here, we can see the 3 different OIDs that deal with auto negotiation, setting the duplex, and setting the speed on the port. So I'm going to do a set, and I'm going to change the speeds on the port. So I'm using port 24, 1/1/24, and that's in bits instead of an integer. So the 2 bits, 0 corresponds to 10 meg support, and 1 corresponds to 100 meg support. So I'm going to both give that a 0 and a 1, and then we can see in my port interface configuration, if I do a SSH session into there, do a show run on the interface 1/1/24, we can see the speeds change to audio, and it supports audio. The speed is set to auto and supports both 10 meg and 100 meg speeds for that. Another new major enhancement for 10.10, AOS-CX 10.10, is we now have the ability to set the view for the SNMP MIBs. So basically, we can limit the view for a community or an SNMP v3 user. Basically, a view will limit how far into the MIB tree can be seen or viewed in that. So with that, there's a new command, SNMP-server view. I've given it here in my CLI example the name limited_view, and then I've limited to this OID. Basically, the last two portions of that OID are 47196.4. I've given it a mask of FF, which in hex, basically anything after that will be included. So I give the command included. You can also do excluded as well. And then I have to also attach that or set that view as part of the SNMP server community, as we see in the next command. And then if I do a show SNMP view, I can see the view that's been set, what the OID tree is included there, what the mask is, and if the status is operational or not. So then, as we see below, if I do an SNMP walk, we can see that after that OID, that there are no more variables left in the MIB view, and that's the end of the tree that we can actually view. So that's how the view works. Let's go ahead and take a look at how some of these work in real time. So I will run some of these commands and show in real time how we can set some of these rights and do the view. So we're going to take a look at the read, some of the important rights, and then how we can limit views using the view command. Let's take a look here at some of these SNMP and SNMP write commands. So first, let's do the read. We're going to do the average CPU and memory. And what we're going to do is we're going to walk this OID here, this .3. So this is the tree for part of the SNMP v2 SNMI MIB. This gives us the average CPU, and average CPU value is .3. And then if we do a .4, that should give us the average memory, which is 27. So then if we have an SSH session into that, we can do a show system. And well, it looks like it dropped to 1 just in the few seconds in between, but we're still about 26, 27 on our memory usage. And let's try to do this quick. We see .4. Let's try to do .3. So we're at 5 now. That's pretty close. So it looks like it's fluctuating a little bit. There we go. And we can run it and see that it's at .5. So that's how we can do the read. We can log into the bash shell of the switch, and then we can run the SNMP commands, SNMP walk, SNMP set, SNMP get. So those are some of the handy commands that we can do on our switch. Let's take a look at PoE priority. So this one I'm actually going to use the MIB name as part of that. So first, though, I want to do a get on this. So let me go back to my command here. I've already have it written, so let's do a get and see what it's set at. Oh, my apologies. I got to move over to my other switch. That one doesn't have access to that. So let's take a look at this one. And what we're going to do is we're going to set it. We're going to set it using this OID. I'm using the actual name of the OID. It's .1.3. So .3 is the port. So we're doing 1/1/3, and we're going to give it an integer of 1, and so that sets it as critical. So now if we exited out of here and did a show run int 1/1/3, we we can see that the priority has been set to critical. Going back to the other switch here, so let's take a look at port security. So what I can do here is let's first, we'll run git. Oops, didn't want that one. I wanted the one that I copied. I'm going to run a git on this OID. So this is running port security for port 25. You can see that it's set to 1. If I go back here to the actual switch CLI, and if I do a show run int, we can see that it's been enabled. So I'm going to reset this to 0 and turn it off, proving that we can set it on this using the command. So set it to 0. Let's go back here, show run int, and now it's been disappeared from the config. So we can turn it on and off via an SNMP set command. And then there's other, as we go further and further down the OID tree, there are other options too that we can set with the port security MIB, the updated port security MIB for 10.10. Let's take a look at port speed in Duplex. So I'm going to run some commands here to get the different values that we can change with that. So the first one, I'm using the mall toggle flag. That gives us the actual name of the OID. That way we can see what the value is. So this is for auto negotiation. So 2 is for auto negotiation, 3 is for Duplex, and then 4 is for interface speeds. If we go back and do a show run on the interface, we can see that it's all set. Oh, I currently have it set to speed and auto 10 and 100. So what I can do is I can reset that. Actually, you know what I'm going to do? I'm going to go into, I'm going to do it from here. I'm going to go in here, and I'm going to do 1/1/24. Speed auto. Show run current. That should reset everything. So then I'm going to go here to the SNMP set, and I am going to set it to 0 and 1, so that sets the speed to 10 meg. This will be auto negotiation, 10 meg, and 100 meg. So if I go back to the interface context, I can reset that, and then I can see that the speed auto has been set to 10 meg and 100 meg. Let's take a look at the SNMP MIB View feature that we have. So this limits the view of how far into a MIB tree a community or SNMP user can view. So we'll take a look at the running configuration on my switch here. So if I look at what I have configured, so I have limited view. So use the SNMP-server view command. I have it named limited view, and then I have this OID here all the way to .4. I give it a mask of FF, so it has to be in hex, so that basically anything after that .4 is not able to be viewed in the tree. And I've included that, so anything with that OID can be viewed until after .4. Then I have to put the view in the community, assign the view to the community that I want to view it through, or the user. And from there I can also do show SNMP view, and I can see all the views I have configured. So here, limited view, this OID tree, mask is FF, it's included. You can also exclude, so you can exclude everything from that and only view after that. And then the status is operational. Let's go ahead and do a walk MIB on that tree. So I'll go back to my start shell, copy my command in here, and then I'll do a view, and it's going to walk through it to the very end of this after .4, and then there's no more variables left in the MIB view past the end of the tree. So that's as far as we can view. So we've proven we can only limit what can be viewed, what OIDs in the tree can be viewed using this command. Thank you very much for watching this presentation. If you have any questions, please reach out to the Aruba Switching TME team, and we'll be happy to answer any of your questions.